Hello, this is Dr. Gorsuch, and I'm in the biology department, and today we're going to talk about one of the problems we are facing in my lab. The big problem is to generate biofuels from waste products. We know that we can generate biofuels from cornstarch with no problem, but there are a lot of economical and agricultural problems to continue that process. It's not feasible. So what we'd like to do is take waste products, say like corn stalks left over in the field, waste products from wood mills and paper mills, and turn those into a hydrolysate, a liquid that the yeast could grow in, and then convert the sugar that's in that are released from those products into ethanol. Now the problem comes that these substrates, the woody substrates and the paper substrates, are very tough, and so it's hard to get the sugars out. So to get the sugars out, you have to throw in a lot of acid. And this acid treatment will release the sugars. Now that's good, except there's two problems that occur. One is it produces a whole bunch of kinds of sugars. Some sugars with 5 carbons, some sugars with 6 carbons. And yeast, the preferred organism to make yeast, only uses 6 carbons. So that's one problem, and we don't work on that problem so much. The second problem is that this acid treatment of these really tough substrates will generate inhibitors. These are byproducts of the treatment of the tough substrates. Many of these inhibitors are aldehydes or acids or hydroxyls that are bad for the yeast. So when you put yeast in the hydrolysate with these mixed sugars, they die because of all these inhibitors that are released. In our lab, we take a genetic approach to try to genetically engineer the yeast. But you could think of another approach that occurs before the hydrolysate's made. So we have, like, say, corn stalks that we're going to treat with acid, and at that time we generate these inhibitors. Maybe there's something we could do so we don't generate as many inhibitors in that process. Alternatively, maybe there's something we could do where when we create this hydrolysate that has all these inhibitors in it, it has over 100 inhibitors, so there's a lot of inhibitors in there. Is there something we could do with that hydrolysate before we put the yeast in? Is there any way we could remediate those inhibitors? And so that's the general basic problem that we're struggling with.